This part of the video is intentionally left blank because I'm going to erase everything I'm saying right here, and I'm going to insert all the bullshit, all the craziness that current folk science, or actually we call it real science, believes. That humans are moldable blank slates, tabula rasa. I'm going to go over that. I'm going to explain how neurons can be conditioned through reward and punishment, and because animals and people are made up of these neurons, we are going to act exactly like a neuron. This is going to be all erased anyway, so due to greater rewards coming from talking than from crying and so forth. So it's this all reward punishment based bullshit that I'm going to pretend that I believe while I'm saying it. So I'll start talking about recurrent neural networks, how they are the wave of the future, how they're going to save us all, and I'm going to pretend that the logical expert systems of the 1980s caused an AI winter. Humans don't think logically, how all binary is brittle, and how it doesn't understand shades of gray. Logic is susceptible to paradoxes, goal is incompleteness, and I won't go into the Penrose argument because that uses religion. Also, but I will explain that logic doesn't account for imagination and adaptation, etc. Explain that humans don't think logically, and so on. Have moved around, and then that's into crawling. Now that we've wasted 2 hours of our lives, I can waste another 4 hours explaining why it won't work. But instead of doing that, I'm going to go right into an alternate theory, which had been developing since the late 60s and then stopped being developed around the early 90s. I probably will waste a little bit of time still on explaining that I did myself believe these things that I said in the previous 2 hours. At least at one point in my life, probably, especially the first 5 years of studying artificial intelligence between 1985 and 1990. But then I was sort of troubled by something called the minimal required representation space and how it just didn't sit well with evolutionary biology. You can explain away a lot of things through evolution and so forth, but what we can't explain is I'd actually let you listen to this previous 2 hours. You'd suppose science would like you to believe that everything that you've ever experienced is locked away somehow neurologically in your mind. Of course we know it is because physically it's there. I'm not going to say that we have like a soul that's projecting or storing our memories for it. But basically, we know just by common sense that everything is somewhere in that bundle of nerves that you've experienced. For example, I was driving to work and the car was overheated on the side of the road. I drove past, so it wasn't a big deal, but I remember that. I can even look over right now in my mind's eye and see that car. You know, if you tried to store a video of my drive to work, which I can remember the entire drive from, it would take a lot of storage. To put this into neurons, my eyes have been operating for several years. I have a lot of data stored. So what just happened when I looked over in my mind's eye and I saw that car overheating? I remember the shoulder had gravel on it, and he was well within on the gravel part. But I was a little bit annoyed everyone was still slowing down, but he was completely out of the roadway, and he was on the gravel. Okay, I could see this in my mind right now. However, I can even tell you the color of the gravel. The picture is so clear. 2.5 seconds I was watching that car while I was driving. Now this is all a memory from about 4 hours ago, okay? So it is fresh in my mind. But am I really looking at a neurological Polaroid or not? Physically, if we were to go into the details of how my anatomy works, I actually am, because there are neurons in my eyes that could have actually put all those pieces there. As I'm sleeping, that neural imprint is going to be put exactly where it needs to be, so that way I can recall it years from now, days from now. And this is pretty acceptable by science. Showed you proof of this, you would not be surprised. Okay, so picture, if you could, the Japanese flag. It's a white flag with a red filled-in circle on it. So as you're looking at this flag right now in your mind's eye, obviously it's probably not a very realistic flag yet. You're just seeing you just created the bare minimum it's going to take to be a flag, or maybe not. Maybe you actually use cloth in your mind. If not, I want you to convert that flag into cloth now. Next, I want you to visualize this flag sort of waving in the wind, like it doesn't have to be on a flagpole. Actually, let's put it on a flagpole. Imagine the wind's blowing it, how it's moving, a really intense, fast wind. Okay, now let's slow the wind down and let's just let it drape there. Notice as it's draped, you can't really see the circle anymore. Enough of the red that you know it's still on the cloth. So this flag has been on flagpole while we watched it blowing. Let's put it onto the last flagpole that we can remember seeing, like in front of the post office, in front of the school, or wherever. Next, I would like you to take that visual image that you have and convert it completely to grayscale. So, like old black and white TV, and where you can still make out the colors, and you can pick up the wind a little bit just so you can see the red disc, now gray disc. Okay, so picture that in your mind and then convert it back to a color image again. What was the point of the grayscale? I wanted to create something that was an unrealistic thing you would imagine. I know some people say they dream in grayscale, but that imagined flag was obviously real. The first flag was realistic. The second one, the grayscale wasn't. So the reason I asked you to picture a grayscale version of this image in real life is I want you to compare it to how realistic it was outside of grayscale. You probably, or actually I could ask which one was more realistic. I would have thought maybe you could answer the grayscale because now you had more processing power to be able to move it in 3 dimensions because you weren't doing color processing, right? No. Or the color was because it actually looked vivid and real. Or maybe what you imagined didn't look very real. But either way, we don't really have a roadmap until you created one. Oh, black and white's less real looking than the other one of what's real and isn't. It's just it's like the old story of the Matrix. And had a person never experienced real life, if you were born into the Matrix, how would you have gotten to know all the same mental images that everyone else sees? It's kind of like the taste of chicken joke in there. How would you know if you saw a flag out in front of your school in the Matrix that it actually looked like a flag would have in reality? You don't know. I'm trying to say is we don't have any exact requirement for realism. And probably no two persons share the exact same amount of requirements for realism. We would assume, though, that someone that had more rods and cones and more neural tissue going into their eyes would have a more realistic mental imprint than someone who didn't. And so anyway, this is really good news for AI science. That since there is no litmus test of realism, there's no way or even need to possibly compare something that's been imagined or not. Tell ourselves what this implies. It means that there's definitely a certain amount of neural processing of images for me to tell a difference between 2 different photographs that I'm looking at. It's been known that when a person is visualizing something like you did with the flag, had we put a monitor electrodes on you, we would have seen you using your vision processing center of your mind. That definitely you were seeing. We could prove you were really seeing it. You weren't just imagining seeing it. So there's some question. If an AGI was to try to visualize something, a visual image, would it only be pretending to imagine it saw an image, or would it actually see an image? But anyway, so mostly I've just been regurgitating crap we already know. But I promise you, on the next video, I will give you part of the breakthrough. Sometimes I feel like I need to prepare for what I'm about to say, prepare this. But maybe I should just do and apologize afterwards. Say it and then explain why, just so these videos are useful. That visual memory, for example, actually superimposes an imaginary thing in which you saw and then compares it to the outside world. And any of the subtle differences that are notable, you imagine those, you superimpose onto the image that you're seeing a better imagined image. And you do this through a process that kind of takes like 3 or 4 cycles until you've gathered to where you're comparing your imagined image to the image that you're actually looking at. So now how you actually store what you just looked at to be able to recall it later is you don't actually store the neural imprints. You store the proto-language in which you use that summon those visuals. So, for example, I believe you are actually born with the thing that allows you to visualize these things. And it doesn't just work for vision, it works with smell, hearing, with all the senses. You can imagine any sort of thing that you can sense. There are many modalities of proto-language. It's a command language. It's also a language in which we think we are experiencing something in. Various society of mind agents throw proto-language towards each other in so like I was explaining, the way the vision system works is your eyes are putting a neural imprint, and then your proto-language is creating a secondary neural imprint. You're comparing the two and then uttering yet another piece of proto-language to edit one until you get the two in sync. But the entire result of that process only returns and throws proto-language your way. So you might actually feel like you're observing what you're seeing because you're missing out on the fact that you've got, one agent completely doing the vision processing by throwing proto-language into your imagination, but being sent onto the neural buffer of that only the vision agent is allowed to see. And I'm going to start talking about agents because, this is sort of about programming, but, interestingly is I think it is also exactly how our biology works, our neurobiology works. If you were to look at the neurology, I believe you're going to find the pieces of the mind that I'm referring to. Anyway, I won't keep apologizing. So proto-language is not natural language. Sometimes it feels like it because I like myself, when I hear myself think, I pretend that it's English. And in a way, we sort of learn to adopt these natural languages for a couple of reasons. One is for the reason we invented logic, and two is for the fact that we can actually start talking while we are using it. I should probably mention the call response system that we use. Speak about call response. What this is the internal instinct that we use to know that a transaction is completed in the proto-language. So, for example, I'm having a great day, amen. The amen there is a response to the call, I'm having a great day. I'm having a great day is a terrible example. Anyway, I'll keep going with it. Is a call is saying, am I really having a great day? Even though you don't realize you're asking yourself that question, and then the response is amen. Or it might be yes. It's just something affirmative. Everything that we have 3 specific litmus tests that we do for our mental evaluation. One is a call response. Another is does it make sense to me? Like, the thought that I just had, when I put it together, did it violate some sort of did it violate some sort of a sequential syntactical rule, which is based only solely on learning from experience? So, yeah, is it a pattern that I recognize? Did I emit a pattern in my thinking that is actually somewhere else? And this sometimes gets confused with associative memory. And the third type of reasoning that we have is this sense of rhythmic reasoning, is we are feeling the pattern to see if we are following a well-known pattern, actually not a well-known, but a becoming a well-known pattern. So now this isn't about English or speech or music. This is purely about how we speak proto-language internally in our minds. However, all these things do end up in these other mediums. They end up in our music. We expect call response in music. We expect rhythm. We expect recognition. So, for example, something that jazz does is it will violate your sequential. It'll keep a rhythm, but then it will also stop violating your sequential. So, hey, I recognize that pattern. So so even though I have 14 random notes, I have the last six notes are the same last six notes that I heard 20 notes ago or 26 notes ago. So what you're doing is you're using the same judgment centers when you're listening to music that you use for proto-language. And when you're dancing, when you're watching art, when you're listening to poetry, you're using those evaluations to judge your connection with the music, the poetry, whatever it is. Also, you use that to be able to understand speech. So from those 3 points of view, I'm saying you are judging your internal proto language.